like to call Mr. Binoy Kumar Das on stage for the next presentation.
Hello. Good afternoon to everyone over here. And I would like to thank iDAC to invite me for this presentations to be agenda speakers as parameters and high-rise for high-rise considerations. So in the previous sessions, already been discussed about lot of about the high-rise structures, which are just creating a skyline form in the urban developments. So I'm just going to present a few slides about for the high-rise, how the facade designs can help from the energy studies like building physics to the facade developments, which can help the architects to find the right way to finalize the type of the systems based on to the requirement. Next slide, please. So, as we are a facade consultant, so we always help support to create the design in terms of the high-rise developments. So here there are a few projects which is being as a references where I've been worked personally in Bangkok, the Kuala Lumpur, which is the super high-rise of 106 story towers. And the projects which is left in the world is the Gurgaon, which is an international financial district. So I would like to talk about the facade requirement for a high-rise structures. So these are a few again current projects where the Nathani Heights, where Mr. Saurabh is self here sitting. Sunshine is just a steel structure building in Mumbai, which is purely in the structure, steel where the facade design, what are the challenges over here on the facade design on the steel structures. The right-hand side on the projects in Bangkok, which is very critical in terms of the crown structures at the roof, and it's belong to a Japanese architect, Japanese firm. So basically, for designing and facade, we normally take up the certain analysis which are very, very essential. We call it the building physics. So these building physics are content of all the analysis factors, which are the wind simulations or wind engineering, which is required for a high-rise structures. That plays a very important role in terms of the defining the facade. The next one, I'll just quickly go through all the analysis. So, as I said, the wind analysis creates a very important role into defining the systems finalization as per the heights of the buildings. So, if you go to the next slides, the next please. Yeah, if we go to the next slides, this is a structure of 192 meters. How the wind engineering or wind calculations can help out in terms of defining the right design on the facade, and also it creates how the value engineering or cost-effective design can be done over. So if you look at this tower, there are different zoning of the wind which has been calculated. So to design the structures in this, we don't need to consider the highest wind load acting on the building. So we can calculate, or we can go with the analysis of the wind simulations and the wind load calculation based on to the height. And for such kind of high-rise, you always has to take a mean wind load acting on the building. And then we design the uniform systems which can go from the bottom to the top of the structures. And wherever the systems has gone over the mean wind load, we can go for some kind of reinforcement inside the aluminum, which can reduce the aluminum consumptions, and it is internationally acceptable everywhere to stiffen the members where there is a deflection concern or the requirement as per the facade wind load. Similarly, the shading analysis or the daylight analysis, these are all important part of the facade which required to be analyzed by a facade engineers or specialists, where the daylight or the shadow analysis can give us the right parameters to be defined in terms of the material selections and also the glass selections around the buildings. Sometimes by working on this kind of analysis, that can also help out to confirm the orientations of the structure or the building based on to the sun path analysis. So when there was some areas where you have a maximum daylight, a maximum solar radiations are into the facade. So that can be also resolved with some kind of solving some inferences over there. And sometimes slight tweaking on the orientations also can help out the facade design to be rightly placed as per the building requirement. Similarly, the same thing in the shading analysis, which is one of the key important part while before we going for the facade design. So this all analysis will help us to define the right materials into the place, to define the correct parameters of the glass specifications required. The most important we found in the facade design is the global UCW, which is called the thermal analysis method. So the thermal analysis is a study between the aluminum and the glass. Normally, for any kind of LEED certified projects, when the LEED ratings requirement, where we get the U value from the LEED agencies. And those LEED requirements, the U value which you are getting is overall surface of the glass. But they are not the expert to calculate the aluminum, the heat which is transferring through the aluminum. So thermal analysis will give you the right data between the aluminum and the glass, the total heat, solar heat gain which is coming through the facade line. So these are important factors which need to be studied during the facade. Next. So these are a few examples how the thermal analysis can help you out to define the right parameters. And this thermal analysis can also help out to design the air conditioning chillers in the inside by the Eminis guys. So when the thermal analysis has been calculated, that can connect to the solar heat gain and non-solar heat gain, and which finally further then calculate to the overall thermal transmission value. So this overall thermal transmission value plays a very, very important role in the facade, where the Eminis guys, they can calculate the total solar total heat gain inside, and that will really help for the air conditioning design to design properly based on to this thermal report. Yeah, that's so these are, as I said, is totally solar heat gain and non-solar heat gain calculations over, and this is how the OTTV calculations can be defined. So in the facade, before designing the systems, we must run through all these analysis to come up with certain common factors where what are the criteria the system should be designed, what kind of glass, the parameters like the thermal, VLT, light transmissions, or solar factor, the U value, relative heat gain, all can be defined through this analysis. So we don't need to rely on the arbitrary the report or figures has been given by the glass people. We can definitely has to calculate what the building required actually. And then we can discuss with the glass manufacturer or the glass expert to match to the requirement as per the shading, as per the color which have been defined by the architect's intent. So sometimes also this overall thermal transmission value plays a very important role, another one in terms of value engineering. How do we, let me define quickly on that in this project, this is a project in Bangkok where as per the code of practice, as per the government regulation, the OTTV requirement for this project was 50 watt per meter square Kelvin. So when we designed this facade, we got a 39 the OTDV rating, so which is far below than the 50 the required. So when we design this facade based on to the analysis, and we find out some kind of cost. So when the facade cost has been the present to the developers and the architects, sometimes the facade design cost is going higher than the budgeted cost, which has been already estimated by the QS department. So what do you do here is that 50 minus 39, there is still an 11 points to play along with the specification. So it does not mean that we are deviating from the specifications, but we have still room to increase some of the points where the cost can be come down. So the value engineering itself is a process which can be which can be start from the beginning along with the design. The value engineering cannot be done at the very difficult to do at the end, the advanced stages where we just only look onto the cutting on the cost without looking at the specifications, or maybe we have to dilute the specification at certain points. So this is very important. So I would like to say that the energy or the building physics, all these analyses are very, very important in terms of high rise. Not only the parameters defined, but also giving a cost-effective solutions through this design. Secondly, as I'm presenting on the high rise only, so the material selections are also very important. So how do we select the materials? On what basis? One criteria. With that, we need to first understood the intent, the architectural intent, which is definitely a architect concept. We need to fulfill that, and the material selections like glass or aluminum cladding or glass reinforced concrete. There are different products can be worked it out based on their specifications or the analysis, and that whether it is really suited to the building in terms of the climatic conditions, whether these materials are can be able to fix it with respect to the local constructability factors. So design can be done as per the highest standard, but we need to also check whether it can be built. The materials can be supplied or built as per the local availability or the constructability factors. So these are certain analysis where of the glass or material or specifications has to go through in a proper way, so that the product which we are specifying into the building should last longer. There are some few examples of the glass calculation, the parameters calculations. So as I said, the parameters can be calculated through all this process which has been defined. So the material selections, again, coming in different types of the patterns. These are different types of the material samples can be looked on as an option to this facade. Few of the concept details, which normally as a part of the details where the facade can be defined at the beginning as a part of the concept and schematic stages. This kind of double screen facade also very important, where, for example, how do we analyze in terms of the patterns selections. In this facade, you see there are the cladding, which is the first screen. You have a solid as well as the perforations. So the perforation hole patterns has to study rightly with respect to the daylight analysis. As a facade engineer or facade consultant specialist, what I will try to see over here is that if the outer screen can be designed properly, then we don't need to have a performance facade in the inside. So we can lower down the performance facade in the inside of in the inside panels, and the heat gain or solar radiations which can be controlled through the patterns which can create. So in this slides, if you see, there are different patterns has been worked it out, where we also try to consider the maximum daylight coming through the screen inside the facade. So as I said, there are different way, the double screen can be treated. So it will be probably with the patterns, one, the performance line, and also the comfort and visibility factors. There are a few, the material selections has been worked out in this project also in the past. Yeah, again. There are a few slides of the material selections for this project. Okay, this is the concept. How do we, like as a facade engineer or consultant, has to take it from the basic concept stages. Like this is a project in Ho Chi Minh City in Vietnam, where the architect intent is showing the facade which is cut at diagonally. And there's a patterns holding the glass with some kind of structures. You can see those yellow lines. So when you study the facade with respect to the intent and also performance and the structural stability, all three are very important. So when you study this facade, we found that there are some structural issues while placing this, designing this facade, which can match into this intent. So we go back to the architects, with the architect team. The next slide, please. So we go back to the architect team, and we discuss with them the problem which can occur in the future about cutting the glass diagonally. So the options which we come out is that we go with this is a hotel project, so we go with a wider the piece of glass in the room, and the same patterns has been followed. The same the intent which this architect has been followed with more visibility in terms of the daylight coming into, or in terms of the wider span is the hotel requirement. So these are the different way the facade specialist or facade consultant can definitely work in hand to hand with the architect team and come up with certain solutions. This is how the facade is. So we are not changing any intent. We just go with the single line of the glass with the rectangular pieces and the trapezoidal pieces. So there are different way the discussion can, the design can bring into the discussion with an architect team. And finally, if they're okay with the concept, then it can go forward. Another few examples are over here is the louvers, the vertical louvers, placement of the louvers. What will be the spacing between the louvers, so that these are all studies which can go through, with different angles of studies, where we can get a better the setting on the facade. Few case studies, the complexity which have been done probably where the facade engineer led. This is one project which is Mumbai International Cruise Terminals, where the complexity lies over here is that it's a triple screen facade, which is a glass reinforced concrete and then fabric. Since these are old structures, we cannot transfer the whole triple screen load into the buildings. So we have to design something which considered to be a vertical loading, 50% vertical gravity loading, and 50% it can go to the structures. So this kind of design really helps to optimize the structure design, and the intent are also possible if it is rightly been structures is out. So this is how the structural integrity of the three screens, which has been connecting each other. And this caters to all your structural requirement, the deflections, the seismic considerations. So everything is designed with respect to the intent has been shown. There are a few slides how the complexity of the design can we take it along with the structures. This is one of the most complex projects in Bangkok, which we have designed in the past, and it is a completed project. The architects is Palmer and Turner from Bangkok. So the whole structures, the facade is twisted. The structure is not twisted. The structure is a rectangular four plate, and the facade has been twisted. So there are a lot of intricacy, there are a lot of complexity required to be handled. So this kind of projects, which is high-rise, we need to have a specialized, the facade guys at the beginning to work with an architect jointly to come up with some kind of solutions which can really help the building to be, the complete with respect to the all required intent and the parameters. Few example of this is that, okay, these are a few details which are coming up. Just go to the next slides. Some integrations into the facade detailings can. This is the one where you have the building twisted. You see the structures, the facade which has been coming out over here is that the twisting is possible only by the facade. So you have the different projection on the facade, which is very important. Designing, yes, is possible, but how can we construct that? That we need to see. The designer always has to also see the constructability factors are possible. So these are the different layers of the facade which is been designed and is successfully been installed in the project. Some of the details, internal and external corners. We can eliminate these slides because we already discussed about why do we need a glass on the facade and how it helps in terms of the aesthetic and the performance requirement. The another very important, we felt that we have started doing onto that is that facade on beam. So normally most of the projects in overseas, what we try to do is that after the concept schematic design has been completed, it's been signed off by the architect, so we go directly into the beam. So we put those facade design intent onto the beam. The benefit of going into the beam is that we can get the correct detail level of detailing. Can go with the correct level of detailing, where facade contractors, especially, they don't need to be struggle with the soft drawings or maybe the percentage of errors are high. But when you use beam on the facade, the design can be quicker, the accuracy will be better because it is working on the software, on the modeling. So also the beam can help on the sustainability, the design in terms of your all analytical part can be put it into the 5D models where the beam will definitely help on energy calculations and all other factors which are required. Most of the complex structure, like double screen or twisted facade or a cantilever facade, or two-way curves. These are definitely benefit when we use a beam, so that beam can give you the right, the detailing in terms of which can lead it to the fabrications, and it makes very easy, very simple in terms of accuracy and also the timely completions of the design and then actual executions. So I would like to conclude this with that facade design is preliminary design itself is very important. So we should always go hand to hand with the architect team during the concept and schematic, where the right facade required by the building is not over designed or under designed, can be placed, can be designed properly, and the facade contractor should have come in the beginning stages where they can also get time to understand the requirement of the facade and the specifications. So this is what about the technical part, but quickly I just go through so few of our projects which has been done globally over. Yeah, next slide, please. So we are present mostly in Asia and India, Asia, and some part of Europe, and we have our own presence and offices where various expertise they help us on to terms of the designing of the facade globally wherever we get an opportunity. And these are the team members. Just next slide, please. Next. Few of the projects, which is this on the right hand side, is Signature Towers is just recently completed, 106 floor. It's because belong to the Mulia Group. And in the center, which is an twisted building, as I've already presented before. So Kuala Lumpur International Headquarter, Airport Headquarter building, which is on the left-hand side, which is one of the green platinum rating buildings. This is, we work with Foster Partner in London for one of the complex, it's a complex project because it's a curved structures with the curved facade and the steel screen. Some projects in Middle East, which is a twisted one. Waterfront Colombo. So there are few high rises we have been walked, and we had some kind of experience which I just share you to why the facade design is important at the beginning stages and how the parameters required to be considered in this. So I'd like to conclude this with my presentation. So thank you so much.